So we talked about what an Arrhenius acid is and what an Arrhenius base is, but it's actually a limited definition of an acid and a base. There's another definition called a Bronsted-Lowry acid and base. And so what we're going to do is talk about that. Now what I'm going to say is, I didn't say this in the last video, but the last video is labeled as pages 9 and 11. That's the PDF page number, not the page number listed on the document itself. So you just need to look at the page number on the PDF because the numbers within the document is not consistent. So this particular page is going to be page 10, and I'm going to go over some of the practice problems on that. And just remember, I'm putting the key to all of this on my website so that you can check yourself if you want. But let's go ahead and get started. So an Arrhenius acid is anything that gives off a hydrogen ion, which I'm going to change that to red. So it's going to give off a hydrogen ion. And a base is anything that gives off a hydroxide ion. Now, what a Bronsted-Lowry acid is, it's something that also gives off a hydrogen ion. And so it's said to be a hydrogen ion donor. And if you really think about it, it's the same sort of definition as an Arrhenius acid. A Bronsted-Lowry acid is a hydrogen ion donor, and an Arrhenius acid is something that gives off a hydrogen as well. But the big difference is the base. A Bronsted-Lowry base is a hydrogen ion acceptor. And so in this particular definition, in this situation, a Bronsted-Lowry base accepts a hydrogen. And so we're going to take look at an example of this. If you take a look, this is again page 10 of the PDF. I know it says page 3 right there, but it's page 10 of the PDF. If you take a look at this equation here, within this equation, as we go from reactants to products, the question is, what is donating a hydrogen ion? Well, if something is donating something, that means that it's losing it. If I were to donate a pen, I'm losing that pen. That pen goes somewhere else. And so in this situation, what is losing a hydrogen as it goes from reactants to products? If you take a look, it's the hydrochloric acid that is losing a hydrogen when it goes from reactant to product. Notice how it lost a hydrogen. So if it's losing a hydrogen, according to our definition, it's a hydrogen donor. So something that loses a hydrogen is a hydrogen donor, which is an acid. So the acid in this situation is HCl. Now, what about the base? Well, what is gaining a hydrogen as it goes from reactants to products? Well, this right here has 3 hydrogens, and now it has 4 hydrogens. It's accepting a hydrogen as it goes from reactants to products. That means the base is the NH3. That's the base, because it's accepting a hydrogen. Now, what type of base is this? It's a Bronsted-Lowry base. Again, an Arrhenius base is something that gives off a hydroxide ion. This is the definition or an example of a Bronsted-Lowry base. Now, we're going to learn in this unit that there are many reactions that are reversible. If you don't quite understand that right now, that's okay because we haven't talked about it, but there are some reactions that can go in the reverse direction. And so what that means is it can go backwards. And so you can see that I'm writing an arrow going backwards. And so if we were to think about the reaction going backwards, what is acting like an acid going backwards? Well, again, if we're going from the products to the reactants and we're going backwards, what is losing a hydrogen going backwards? This happens to be losing the hydrogen. And what that happens to be called, it is an acid, but it's called the conjugate acid. Now, let's talk about, well, what is acting like a base going in the reverse direction? Well, we've got Cl1 minus here. And again, a base is a hydrogen acceptor. And so I'm going to go ahead and clean this up a little bit. So this right here, when it goes backwards, it's accepting a hydrogen. And again, a hydrogen acceptor is a base. So the conjugate base happens to be this. All right, let's go ahead and take a look at this next example here. In the forward direction, going from reactants to products, what is losing a hydrogen? Well, it's the HCN. If you take a look, the HCN is losing a hydrogen as it goes from reactants to products. That means that the HCN is an acid. Now, what is gaining a hydrogen going in the forward direction? Well, if you take a look here, this is OH and it becomes H2O. So it's gaining a hydrogen. So the OH1 minus is accepting a hydrogen, which makes it a base. Now, what about in the reverse direction? Again, we're going to learn about reactions going backwards. Well, what's acting like an acid in the reverse direction? Well, again, an acid, a Bronsted-Lowry acid, is losing a hydrogen. And so what is losing a hydrogen in the reverse direction? Well, it's the H2O. The H2O is losing a hydrogen in the reverse direction. And what is gaining a hydrogen in the reverse direction? What's accepting a hydrogen? It's the CN1 minus. Now, what I want to point out here is notice that whatever is originally an acid always becomes a conjugate base. And notice that whatever is a base will always become a conjugate acid. And so the base becomes the conjugate acid, same thing here, and the acid becomes the conjugate base. And it's the same thing here. And so that's going to be the case every single time. Okay, let's go ahead and skip down to this problem here. And let's go ahead and talk about how we do this. Well, this is already telling us what is the acid. It's saying that the acid is HNO2, which is nitrous acid. And it's telling us that the base is the water. Now again, an acid is something that loses a hydrogen, and a base is something that gains a hydrogen. And so if the HNO2 is the acid and it's losing the hydrogen, that means it's going to become NO2, 1 minus. Now the H2O is gaining a hydrogen to where it becomes H3O, and because the hydrogen is a positive ion and it's gaining that positive ion, it becomes a 1 plus. So again, this is an acid. It's losing a hydrogen to become this. This is a base. It's gaining a hydrogen to become that. So what's acting like an acid backwards? Well, the H3O. Because again, whatever's the base becomes the conjugate acid. And whatever is the acid becomes the conjugate base. Because in the reverse direction, the opposite occurs. So go ahead and do these practice problems, and the key, again, is on my website.